Good day, Husayans! I am Ma'am Maka, the matayahing teacher, and I'm here to guide you in your lesson on identifying test statistic for population mean, specifically Z-test. Statistics play a very important role in understanding numerical information to make an intelligent and sound decision. Thus, statistics is a tool in decision-making in various fields like business, math, science, economics, accounting, banking, government, agriculture, engineering, planning, research, and education. Test statistics is a statistical method structured to convert and analyze the sample data. It is used to determine that evidence shown is convincingly contradicting the null hypothesis. Let us recall the steps in accepting or rejecting a hypothesis. First, we state the null and alternative hypothesis. Second, we determine the level of significance. Third, we select the test statistics. Fourth, we compute the test statistic value. Fifth, we determine the critical value. And lastly, we draw a conclusion. The Z-test and T-test are two statistical tools used in hypothesis testing concerning means. In this lesson, we will tackle test statistics on single population mean using Z-test. The Z-test is used to test hypotheses that involves a single or two sample means. It may also be used to test for the difference between proportions. The following are the basic assumptions for Z-test. Population standard deviation is known. It should be noted that the sample standard deviation is a good approximation of the population standard deviation if the sample size is large. The sample size is large or N is greater than 30. The population is approximately normally distributed. Samples, which are independent samples, are randomly selected. The formula for Z-test: Z value is the difference of sample mean and the population mean all over population standard deviation divided by the square root of sample size. Let us see how Z-test is applied in this example. Assuming this situation, the head of Baguio Tomay Jeepney Operators and Drivers Association, or BADJODA, claims that the average daily take-home pay of jeepney drivers with daily boundary is 520 pesos. Since the price hike occurred, 50 random jeepney drivers were interviewed and said that their daily take-home pay is 545 pesos. Use a 0.05 level of significance to find out if the average daily take-home pay of jeepney drivers is different from 520 pesos. Assuming that the population standard deviation is 75 pesos. To find out if the average daily take-home pay of jeepney drivers is not 520 pesos, we follow the steps in testing the hypothesis. Step 1. State the null and alternative hypothesis. Our null alternative hypothesis, the average daily take-home of jeepney drivers with daily boundary is 520 pesos, or in math form, mu is equal to 520. For alternative hypothesis, the average daily take-home of jeepney drivers is not 520 pesos, or in math form, mu is not equal to 520. Step 2. Determine the level of significance. The level of significance, which is alpha, is equal to 0.05. Step 3. Select the test statistic. Let us check if the basic assumptions for Z-test are satisfied in the problem. 1. Population standard deviation is known, which is 75 pesos. The sample size is large since 50 is greater than 30. We assume that the population is approximately normally distributed. The samples, which is 50 jeepney drivers, are randomly selected. The other given is the sample mean, which is 545 pesos, and the population mean, which is 520 pesos. Since we satisfy the assumptions, then z-test is applied. The formula for z-test is where z is the z-value, x bar is the sample mean, mu is the population mean, sigma is the population standard deviation, and n is the sample size. Step 4. Compute for the test statistic value. We substitute the given to the formula for z-value, that is 545 minus 520 all over 75 divided by square root of 50, which is equal to 2.357,000 or 2.36. Step 5. Determine the critical value. The alternative hypothesis is non-directional since population mean is not equal to 520 pesos, meaning there will be a difference in the average take-home pay of the jeepney drivers. Hence, the two-tailed test shall be used. Divide alpha by 2, then subtract the quotient from 0.5, which is half of the total area under the normal curve. We substitute our level of significance in the formula. Hence, alpha divided by 2 is equal to 0.05 divided by 2 is equal to 0.025. We subtract 0.025 from 0.5, which is equal to 0.475. Using the areas under the normal curve table, the area 0.4750 is under column headed to 0.06 and under the row 1.9. Therefore, z is equal to 1.96 at 5% level of significance. The critical values are positive, negative 1.96. Step 6. Draw a conclusion. The computed test statistic value 2.36 falls within the rejection region, meaning the z-value is greater than the critical values. Then, we reject the null hypothesis. Therefore, we can conclude that the average daily take-home pay of jeepney drivers is not equal to 520 pesos. Determine whether z-test is applicable in the problem using the steps in hypothesis testing. You have 5 seconds to answer every question. However, if the time is not enough, you may pause the video and think of an answer. A manufacturer claimed that the average life of batteries used in their electronic games is 150 hours. It is known that the standard deviation of this type of battery is 20 hours. A consumer wished to test the manufacturer's claim and accordingly tested 100 electronic games using the battery. It was found out that the mean is equal to 144 hours. At significant level of 0.05, is the average life of batteries used in electronic games different from 150 hours? What is the null and alternative hypothesis? If this is your answer, great job! What is the level of significance? If your answer is 0.05 level of significance, you are correct. Let us check if the basic assumptions for z-test are satisfied in the problem. 1. Is the population standard deviation known? If you said yes, you did an excellent job. The population standard deviation is 20. Is the sample size large? Yes. Did you get the correct answer? If yes, well done! Since our sample size is 100, which is greater than 30. We assume that population is approximately normally distributed. The samples, which is 100 electronic games, are randomly selected. Did we satisfy the assumptions? Yes. Therefore, z-test is applied. Let us identify the other given in the problem. What is the sample mean? If your answer is, you are right. What is the population mean? If you said, you are doing a great job. What is the formula for z-test? If your answer is, you're doing a fantastic job, compute the test statistic value. If you have this solution, then you are correct. We determine the critical value. The alternative hypothesis is non-directional since population mean is not equal to 150, meaning there will be a difference in the average life of batteries used in the electronic games. Hence, the two-tailed test shall be used. Divide alpha by 2, then subtract the quotient from 0.5, which is half of the total area under the normal curve. Substituting the values, then subtract 0.025 from 0.5, which is equal to 0.475. Using the areas under the normal curve table, the area 0.475 is under column headed to 0.06 and under the row is 1.9. Therefore, Z is equal to 1.96 at 5% level of significance. The critical values are positive, negative 1.96. What now is our conclusion? The computed test statistic value negative 3 does not fall within the rejection region. Then, we fail to reject null hypothesis. We can conclude that the average life of batteries is 150 hours. These are the steps we apply to identify the test statistics to be used. The z-test is to be used in hypothesis testing concerning means. When population standard deviation is known, the sample size is large or the population is approximately normally distributed, samples which are independent samples are randomly selected. And that is our lesson on identifying test statistics, particularly on z-test. I hope you grasp all the concepts. Again, I am Ma'am Macareya, ending our lesson with a quote from our Bishop Victor B. Bendico. Let us not live with the standard of the world, rather by the standard of the Lord.
So